So hi everyone. So this is Dr. G.Ravindranath Reddy, working as Assistant Professor of Mathematics in MLR Institute of Technology, Hyderabad. So in this video, we are going to discuss how to find out the Fourier series of f of x in an arbitrary interval. So in the previous videos, we have seen how to find out the Fourier series of f of x in the interval 0, 2 pi and minus pi, pi, and in the interval 0, pi for both continuous and discontinuous functions here. So now, Fourier series of an arbitrary interval we are going to discuss. So in this video, especially in this arbitrary interval, so we are going to discuss how to find out the Fourier series of f of x in the interval 0, 2l. I have seen this minus pi, pi and 0, pi. The length of these two intervals are 2 pi. Similarly, we are going to discuss not the length 2 pi, but we are taking some quantity as 2l. Now that we can consider as arbitrary interval. So in this we are going to discuss three types of intervals, that is 0, 2l. The length of this interval is 2l, and minus l, l. In this also the length of interval is 2l, and here we are going to discuss. So now, Fourier series. So I discussed in the previous class, we have seen this minus pi, pi and 0, pi. The length of these two intervals are 2 pi. Similarly, we are going to discuss not the length 2 pi, but we are taking some quantity as 2l. Now that we can consider as arbitrary interval. So in this we are going to discuss three types of intervals, that is 0, 2l. The length of this interval is 2l, and minus l, l. In this also the length of interval is 2l, and here we are going to discuss 0, another interval 0, l, and the length of this interval is only half of the length of these two intervals. Now we will see what is the standard formula to find out the Fourier series of f of x in the interval 0, 2l. So this is given by f of x is equal to a0 by 2 plus summation n is equal to 1 to infinity an cos n pi x by l plus summation n is equal to 1 to infinity bn sin n pi x by l. So this is the standard formula we will use to find out the Fourier series of this function in the interval 0, 2l. And here we are having three coefficients a0, an and bn. Now we will see what are the formulas we are having to find out the values of a0. So a0 is given by 1 by l integral 0 to 2l, because we are taking the interval 0 to 2l. So that's why we have to take the integral limits as 0 to 2l and f of x dx. And an is equal to 1 by l integral 0 to 2l f of x into cos n pi x by l into dx. And bn is equal to, this is the another coefficient, bn is equal to 1 by l integral 0 to 2l f of x into sin n pi x by l. So this is the formula we will use to find out this Fourier series of f of x in the interval 0, 2l, and these are the formulas used to find out the coefficients of a0, an and bn values here. Now let us take one example how to find out this Fourier series of this function, and the interval he has given as 0, 2. So whenever we want to find out the Fourier series in the interval 0, 2, then immediately we have to compare this interval with 0, 2l. Now we will see what are the steps involved to find out this Fourier series here. So here the length of the interval, we have to compare this interval 0, 2l. So the length of the interval is given by 2l, and this is equal to 2l is equal to 2. Now here we can, from this we will get this value l is equal to 1. Now as usual, as we discussed in the previous slide, so this is the standard formula we will use to find out the f of x value here. Now a0 value. So now this is our standard formula. This standard formula is applicable for the interval 0, 2l. Now we are having the interval, we have given the interval as 0, 2. Now by comparing these two intervals we got that l is equal to 1. Now in this standard formula I have substituted the value of l here. So this is the standard formula to find out the Fourier series in the interval 0, 2. Okay. So wherever we are having l in the standard formula, replace that l with l is equal to 1 here. So you will get a0 by 2 plus summation n is equal to 1 to infinity an cos n pi x by l. So in place of l, here we have replaced with 1 that is nothing but n pi x, plus similarly summation n is equal to 1 to infinity bn. So here we are having L, so replace that L with 1, so you will get sin n pi x. So this is the standard formula to find out the Fourier series in the interval 0 comma 2. Now a naught, first we will take the standard formula in the interval 0 comma 2l, and then we will replace that L with 1, then we will get our standard value, standard formula to find out the a naught. So a naught is equal to, so 1 by L, L is equal to 1, so 1 by 1 you will get 1, and integral 0 to 2L, so this can be written as 0 to 2 because 2L is equal to 2 here, so replace the 2L with 2 into f of x dx. And similarly an, this is our standard formula what we have discussed in the previous slide. So now replace L with, so L with 1, so 1 by L, that is 1 by 1 1, and 0 to 2L can be replaced with 2, and f of x into cos n pi x, L is nothing but 1, so cos n pi x dx. And similarly, so bn is equal to, so bn is equal to, this is the formula, replace L is equal to 1, you will get bn is equal to integral 0 to L f of x into sin n pi x dx. Now one by one we will, by using these formulas one by one we will find out the value of a naught, an and bn here by substituting the f of x given in the problem. So now a naught is equal to, now we got integral 0 to 2 f of x dx, replace that a naught f of x value with this pi minus x by 2. So now we have to apply the integration with respect to x. So pi is constant, so take this denominator outside, so 1 by 2 into the pi is constant here, integral of pi we can take it as pi x minus x, integral of x can be written as x squared by 2, the limits are 0 to 2. Now substitute the upper limit and lower limit here. By substituting the upper limit and lower limit you will get that value is equal to pi minus 1. So this pi minus 1 is the value of a naught. So this is equal to a naught value here. Now take the next one, an is equal to, so integral 0 to 2 f of x cos n pi x. Similarly here also you substitute the value of f of x, you will get pi minus x by 2 into cos n pi x dx. Similarly here you take this denominator outside, so you will get that value is equal to 1 by 2 integral 0 to 2 pi minus x into cos n pi x. So this pi minus x we can consider as algebraic function, this cos is a trigonometric function. So inside the integral you are having product of two functions, so you have to apply integral of uv. So you consider this as u and consider this as v. Now integration of uv, so u into integral of this cos n pi x, so you will get integral of cos is nothing but sin n pi x by n pi minus derivative of this, that is pi minus x, that derivative of pi minus x minus 1, and integral of this v1. So integral of v1, integral of sine can be written as minus cos n pi x by n square pi square. So as we discussed in the previous videos, and this formula is given by integral of uv. So this is equal to u into v1, that is integral of v, minus u dash into v2, that is integral of v1, and we have to apply this formula until we get the derivative of this u as a constant value. So here we got the constant value derivative of u, so we can stop this. So now you simplify this here. So if you simplify this here, pi minus into minus plus, plus into minus, you will get minus. So finally 1 by 2 pi minus x into sin n pi x by n pi minus cos n pi x by n square pi square. Now we are ready to substitute the upper limit and lower limit here in place of x. So now substitute x is equal to 2 in the upper limit of x, that is 2. So you will get pi minus 2 sin n pi x, here we are having x, so substitute 2, you will get sin 2 n pi by n pi minus, similarly replace x with 2, here you will get cos 2 n pi by n square minus n square pi square minus. Now in this you substitute the lower limit, x is equal to 0, pi minus 0, that is pi, and sin n pi x 0, sin 0 is 0, and cos n pi x into 0, that is cos 0 here. Now sin n pi, we know that that value is equal to 0, and cos 2 n pi, this we can consider that value is equal to 1, and here sin 0 is 0 and cos 0 is 1. Now, so since sin 2 n pi is 0, so 0 into anything equal to 0, this total term becomes 0. So the remaining one is minus cos 2 n pi is 1, so this can be written as, next step you can take this minus, this is 0, here minus into minus, plus cos 0 is 1, 1 by n square pi square. So now take this, I have taken this denominator n square pi square outside, so finally you will get this value. So this cos 2 n pi is 1, so 1 minus 1, you will get 0, 0 into anything equal to 0. So finally we will get that a n value is equal to 0. So a naught is equal to pi minus 1 and a n is equal to 0. Now we will go for b n here. So Bn, this is the formula we will use to find out the value of Bn. Similarly, substitute the value of f of x, that is pi minus x by 2. Take this denominator to outside. So integral 0 to 2 pi minus x into sin n pi x. Here also you apply the integral of uv. You consider this pi minus x as u and sin n pi x as v. So as we discussed in the previous, so apply the same formula here. So you will get this value is equal to u into integral of v, that is integral of sin n pi x, this can be written as minus cos n pi x by n pi, minus derivative of u, that is derivative of pi minus x, pi is constant, minus derivative of x is 1, so 0 minus 1, you will get minus 1, and this, find out this integral and write down here. So a minus cos, integral of cos can be written as sin n pi x by, already here we are having n pi. Once again, if you apply the integration for this, once again you will get the denominator as n pi. So n pi into n pi, you will get n square pi square. Now simplify this. So minus of pi minus x into cos n pi x by n pi, and here minus into minus, minus into minus plus, plus into minus, minus sin n pi x by n square pi square. Now substitute the limits here. So put x is equal to 2 here as usual. So minus of pi minus 2 cos 2 n pi by n pi minus sin 2 n pi by n square pi square. So this is the value after substituting the upper limit here, upper limit, and now minus lower limit. Now here you substitute x is equal to 0 because our lower limit is 0. So minus of pi minus 0, and here x is 0. So you will get cos 0 by n pi minus sin 0 by n squared pi square here. So this is the value you will get after substituting the lower limit here. Now simplify this here. So minus of pi minus 2 into cos 2 n pi and sin 2 n pi is 0. So we can neglect this, and here we are having cos 0, that is 1. So minus of minus plus pi into cos 0 by n pi, and sin 0 is 0 here, so we can neglect 0 by anything equal to 0, so we can neglect this term. So after getting these two sign terms as zeros, finally we got this is the value. Now in the next, you substitute that sin cos 2 n pi and cos 0 here. So this pi and this pi gets cancelled, or if you want you can take that n pi outside, this n pi and this n pi we can take outside. So minus also taken outside common. So minus 1 by 2 n pi, pi minus 2 into cos 2 n pi. So if you take minus outside, this plus becomes minus, the remaining one is pi. So cos 2 n pi, we can take this value is equal to 1. So 1 into pi by 2, sorry 1 into pi minus 2, so pi minus 2 minus pi. So this pi and this pi gets cancelled. So minus into minus plus, this 2 and this 2 gets cancelled. Finally you will get this value is equal to 1 by n pi. So we got Bn is equal to 1 by n pi. So now we got A naught value, A naught we got the value of A naught, and we got the value of An, and we got the value of Bn. Now you substitute all these values in our equation 1. So this is the function f of x is equal to, so since we got An is equal to 0, so in our standard formula we can neglect this summation, this term n is equal to 1 to infinity An into cos n pi x. So we can neglect this because we got this value is equal to 0. Now the first term is A naught by 2, A naught we got that value is equal to pi minus 1 by 2 plus summation. So this An term is 0, so we can neglect the second term. Now you consider that Bn term, that is third term, summation n is equal to 1 to infinity Bn, we got that Bn is equal to 1 by n pi sin n pi x. Okay, so this is the way how we can find out this Fourier series expansion in the arbitrary interval 0, 2l. Now in the next video we will go how to find out the Fourier series of expansion for the given function f of x in the interval minus L, L. So whenever we are having the interval minus L, L, here that function we can consider as the function may be an even function and function may be an odd function between the limits minus L to L, or the function may be neither even nor odd. So in the next video we are going to define what is an even function, what is an odd function, what is neither even nor odd. Okay, thank you all of you.